Hello everyone, I'm Emre Koçyiğit. I'm a doctoral researcher in the University of Luxembourg, and in this video series I will explain large language models. It will be a comprehensive video series. At the beginning I will make an introduction and I will explain the theory behind the large language models. Why are these large language models, LLMs, are so powerful, important and also popular today? And for the theoretical part, the major source will be this survey article, a survey of large language models. It is published in this year, 2023. It's a bit long, but it provides the big picture quite well. And I strongly recommend this paper, this article, if you want to increase your expertise and go deeper. After the theoretical part, I will show a couple of practical examples. I will use OpenAI API, and also I will show how can you use open source LLMs from transformers. And I hope at the end this video series will be quite beneficial for you and informative. First of all, I want to show the position of large language models in the AI world, in the language modeling. So LLM stands for large language models, but what are the other language models? If you look at language models, chronologically, we can start from statistical language modeling. N-gram models are one of the examples of these statistical language models, SLM. We can use different techniques, statistical techniques, and we can compare the documents, for example, and we can understand the similarity of the documents. Or you can define n-gram based rules and analyze the documents. And of course, these models are not sufficient to solve different complex tasks. Then we have neural language models, NLMs. Artificial neural network architecture is quite helpful to solve different problems, and in the NLP, we have recurrent neural network type. Since it can be used for the sequential data and the text data is a sequential data, we can use RNN, but we know that RNN had problems with long memory, especially when you feed the model with longer inputs, longer text, then model couldn't remember the first inputs. To solve this problem, we have LSTM, long short-term memory, and then word-to-vec model was developed. This is an important milestone in the NLP. We can use embeddings to represent the tokens. You can imagine these embeddings as vectors, and we can describe the tokens, the words with different dimensions thanks to these embeddings. And then we can check the semantic similarity of different words. And you can check the common example of word-to-vec. For example, model can understand the relationship between queen and woman. Then when you give king, and model can fill this part as man. But these are single task specific models, not complex and multitask solver. Then we have pre-trained models. And one of the first example of these PLMs are Elmo, BLSTM, BERT, and especially BERT is an important milestone. The size of the model and the dataset size is bigger than the previous model, and GPT-2 and BERT can be categorized as PLM. Then we have large language models, and you will see that the architecture is similar with PLM in LLM, but scaling PLMs, increasing the model size and dataset size, we can obtain large language models. For example, GPT-2 is a PLM and it has 1.5 billion parameters and it cannot solve few-shot tasks, but with large language models, for example GPT-3, we have a model which has 175 billion parameters and it can solve few-shot tasks by in-context learning, and these tasks cannot be solved by the PLMs. And of course, after ChatGPT, these large language models are quite popular. If you look at this graph, the query of large language model trends increased dramatically after the ChatGPT. And today you can see large language models, LLMs everywhere. Okay, I said that PLMs and LLMs have similar architectures, and the difference is mostly about the model size and the dataset size. But what are the consequences of these differences? Let's compare LLM and PLM. First of all, in LLMs, we have emergent abilities. And simply, these abilities are not available in PLM. And thanks to these abilities, we can solve very complex tasks. And these abilities makes AI algorithms unprecedentedly powerful and effective. I will elaborate this part. For the moment, you should know that the LLMs, some abilities which are not available in PLM, but they are very important and they increase the performance of the LLM in different tasks. Also, the LLM revolutionized the way that humans develop and used AI algorithms. Today we have ChatGPT and also we have different APIs. For example, we have OpenAI API and prompting interface. And this is not only for the researchers or big companies. Today, everyone can access it, and the developing and using the AI algorithms is changing thanks to this prompting interface and APIs. And another aspect is in the LLM, there is no clear distinction between research and engineering. So we need practical experience, we need large-scale data processing, hardware infrastructures, distributed and parallel training, and the field is quite dynamic and it's evolving day by day. Therefore, the research and the engineering industry and the universities, they should be together, they should work together, and there is no clear distinction. Also, after LLMs, the possibility of AGI, artificial general intelligence, has been discussing now, and for example, GPT-4 is accepted an early version of AGI. Even this early version of AGI is quite powerful and it is transforming everywhere, not only the AI community. And also, you can see that these LLMs, after these LLMs, information retrieval, computer vision, and regular tools, plugins, browser extensions, they are also changing. Today, instead of only Googling, we can use these LLMs to get the information, to retrieve the information, to find our answers. Okay, LLMs are so powerful, popular, they are solving different tasks, but is everything perfect in LLMs? Of course not. Let's look at some issues. First of all, yes, they are so powerful, and behind this power, we can see emergent abilities. I will elaborate this part, okay? But we have a problem. These abilities are not completely explored. So there is a black box here. The research is ongoing about these emergent abilities and the behavior of the large language models, but still not completely explored. Also, this field, LLMs, is not easy to research because it requires huge computation resources. We have billions of parameters and huge amount of data sets. Therefore, we need a lot of computational resources. For small companies, for small teams, it's not very applicable. And also, due to these requirements, the industry is leading this field. And we have some open source studies, but not all studies are publicly available. And another and very important aspect that these large language models can be used, for example, as a chatbot, and everyone can interact with these models and ask different questions. But the questions also can be quite dangerous. Someone can just ask, how can I make a bomb, chemical bomb? Of course, these LLMs should not provide the answer, right? So these LLMs should be aligned with human values. They shouldn't be toxic, harmful, or hallucinative. In the hands-on part, I will also elaborate this part. Okay, after this soft introduction, now let's look at the fundamentals of LLMs and the characteristics of LLMs.